So yesterday we were doing sequences, where sequences are just a list of numbers in a set of ordered numbers. Okay? And today we're going to look at series and summation notation. Well, what a series is basically just taking that sequence and adding those numbers together. Okay? So the sequence, we're just listing the numbers, separating by commas. And with a series, we're actually going to find the sum of those numbers. And what we're going to be doing here is we're going to be just finding what's called a partial sum. Because with a partial sum, we're just looking at a certain amount of numbers, where we will look at infinite sums in the very last lesson that we do in this chapter. But right now we're just going to look at a partial sum, which is just using a certain number of them. Okay? So here they show sequences. Here's what the sequences would look like. And then if I had it as a series, then it would look like this. So we just then are adding them together. So the only difference between sequences and series is that we're finding the sum. Then we have this thing called summation notation. This is the Greek letter sigma, capital letter. And we're going to be using sigma to represent summation notation. And here's how summation notation works. That this means, the sigma means the sum, and underneath it is the first number we're going to start with, and usually we use k for summation. So from k starts at 1 and goes to 5, and then the rule, the explicit rule we would use would be 2k in this situation. So, which is this right here, which says that I'm going to do this. I would put 1 in for k, and then 2 in for k, and then 3, and then 4, and then 5, and add them up. Okay? So this summation here, when it says the sum of 2k is k goes from 1 to 5, what that means is I'm going to start, put 1 in for k, so I have 2 times 1, then plus 2 times 2, plus 2 times 3, plus 2 times 4, plus 2 times 5. And then I would find that sum. Okay? That's what this means. Okay? So basically all we're doing is they give us the explicit rule, and we stick the numbers 1 through 5 in for k and add them up. Okay? So here we have the series 4 plus 8 plus 12 plus 16 plus 20. And we want to find a rule for the kth term of the sequence. So basically we're going to find the explicit rule for this series. All right, so we're going to use our table like we were working with yesterday when we were trying to find the explicit rule. Why I put x and y up here, I'm not sure, but they're kind of like x and y. So we have our term, x would be our term numbers, 1 through 5. Okay. And then y would be the values we get, 4, 8, 12, 16, and 20. So now, is this linear, quadratic, or exponential? We need to know that, don't we? Okay, to be able to find the explicit rule. What are they doing each time? Adding 4. Okay. So the conversation we had a couple minutes ago was the fact that if it's linear, it's going to be whatever my rate of change is times k. And then if we went back 4, where would I be at? Be at 0. Okay. So this would be 4k plus 0, or just 4k. Now let's make sure we all agree with that then before we go on then. Okay. So here we started with 4. This is 4, or this is 4 plus 4 times 0. Okay. Then 4 plus 4 times 1. 4 plus 4 times 2. Right? You get, okay, we started our first number in our series is 4. And then to get from 4 to 8, I'm adding 4. To get from 8 to 12, I add 4 a second time. Get to 16, we add 4 a third time. And then add 4 a fourth time. So our value of k here then, it would be 4 plus 4 times k minus 1. Because these numbers over here, 0, 1, 2, 3, and 4, are 1 less than the value of k, or the value of n we were using yesterday. So if we simplify that, it would just equal 4k. But like I said, if we're talking about linear, find the rate of change, okay, the first difference, okay, which in this case is 4. Multiply that by the variable we're using. If we're doing summation notation, we're using the variable of k. And then go back that number from the first term to term 0, okay, and you would find your, basically your y-intercept. So if I write it in summation notation then, I make sigma, which some of us are better at drawing sigma than others. And k is going to start at 1. And since we have 5 terms in our series, it goes to 5. And then the explicit formula here would be 4k. So this is similar to what we did yesterday as far as finding an explicit rule. Instead of using n, we're using k. And then you're starting at what number do I start at? What number do I end at as far as your term numbers? Term 1 to term 5. All right, so let's look at another one. Now over here, we have a little note, a caution that we have to be advised of. That in this situation here, we have alternating signs. So -1 plus 1/4, minus 1/9, plus 1/16, minus 1/25, and plus 1/36. So it says for sequences with alternating signs, then we're going to end up using -1 raised to the k plus 1 power if the first term is positive, and -1 to the power of k if the first term is negative. And we'll talk about that a little bit more as we do this. Now, in determining the explicit rule, we're going to ignore the plus or minuses, okay? So to find the explicit rule, if it alternates signs, ignore the signs. So we've got terms 1, 2, 3, 4, 5, 6. So we got 6 terms. Right, and so we have 1, 1/4, 1/9, 1/16, 1/25, and 1/36. So if all we pay attention to is those numbers, okay, how does our term number, 1 through 6, how is it located in our term values? Can you see, Lauren? Okay, we're squaring it, okay? So I've got 1 over k squared, right? It's in the denominator. So this is 1 over k squared. Now, once we've figured out what the explicit rule is, ignoring the alternating signs, then we need to look at our very first sign, which is negative. And if it's negative, that means then we're going to use negative 1 to the power of k. So this is going to be, our rule is going to be, so our explicit rule is negative 1 to the power of k times 1 over k squared. So here k is going to go from 1 to 6 because we have 6 terms. Now sometimes, I want you to understand something, you don't always have to start at 1. You could start at 2 or 3 or 4, okay? It doesn't matter where you start as long as you get the beginning to the end. And this would be negative 1 to the power of k times 1 over k squared. And we'll check this just to make sure that that is correct. All right. So now, if I put 1 in for k, what's negative 1 to the first power? Negative 1 to the first power is negative 1, right? Okay. And then 1 squared is 1, so we'd have negative 1 times 1, which is negative 1. Okay, that works. If we put 2 in here for k, what's negative 1 squared? Positive 1, right? Because negative 1 times negative 1 is positive 1. Positive 1 times 1 over 4 is positive 1/4. Okay. So if the term number is odd, whenever I have an odd number that goes in here for k, we would end up with a negative value. Term 1 is negative, term 3 is negative, term 5 is negative. Terms 2, 4, and 6 are all positive. So this would produce first a negative number, then a positive number, then a negative, then a positive, then a negative, and a positive. Okay. To where if we use the k plus 1, whenever I had an odd term number, it would make the k plus 1 even. Okay, does that make sense? Because if I put 1 in here for k plus 1, I'd have negative 1 squared, which is a positive 1. If I put 2 in there, I would get negative 1 cubed, which is a negative 1. Okay? So anytime it starts out negative, we have to put negative 1 to the power of k in front. Whenever it starts out positive, we would put negative 1 to the power of k plus 1 in front. All right. So evaluating a series. So if they give me a summation notation and they ask me to evaluate it, that means I'm just going to find the answer. Here they're asking us to expand it and evaluate it. So that means we have to write it out, okay? Write the complete thing out, and then find the answer. Okay. And then here's another caution for us. Watch out. Series can have a first value other than k equals 1, so make sure that when you use the right number. So in this case here, Where's it starting? Okay, starts with 2, doesn't start with 1. So I'm going to go 1 over 3 squared plus 1 over 3 cubed plus 1 over 3 to the 4th plus 1 over 3 to the 5th. Okay. Start with 2, put that in for k, and then keep putting the numbers in for k until I get to the number on top, which is 5 in this case. And then we're going to add them up. And since we have our most amazing calculators that will add fractions for us, you might as well use those to add your fractions instead of finding a common denominator to do that. Unless you like fractions, then you could get a common denominator. And add them up, and you get 40 over 243. Or use your calculator and do it if your brain doesn't work so well. So is that little sigma, is that easy to do? Kind of like doing braces, you know. There you go, there's a brace. You know, a couple squiggles and you got it. Really? Hmm. You did it? Yeah. Yeah. Oh, so doing the braces, she made you practice them then. Yeah. Probably when you're doing roster notation like that in algebra A or B. Yep. Okay, so k squared minus 10 from 1 through 6. So we're going to need use some parentheses here. So 1 squared minus 10. So we'll put 1 in for k, and then 2, 3, 4, 5, and 6. Okay. So we write it all out. We put 1 through 6 in for k. So then we have 1 squared minus 10 is negative 9, plus 4 minus 10 is negative 6, 3 minus 10, negative 1, or 9 minus 10 is negative 1. 16 minus 10 is 6. 25 minus 10 is 15. And 36 minus 10 is 26. And then we just add them together. And we get 31. That's pretty easy, isn't it? All right, just plugging them in and find the sum. This one was really nice to add together because we had matching sixes. You get rid of the sixes. Positive 6, negative 6, we could cancel them, and so on. All right. Oh, yeah, this would be good practice. Let's do B. Just so you practice with a negative in the k minus 1. So, letter. Now, there are some formulas to help you if you have a series that is a linear series or a quadratic series or what they call a constant series. And now I'm going to show you these formulas that you can use to find those answers quickly. But the thing is that you don't have to use them. Okay? You can always just take the numbers and add them together. So for instance, okay, here are 3 different ways to find a series. So if we have a constant series, then however many times we're adding that constant together, we could just multiply those together. Okay? So like here they show an example of adding 3 together 5 times. So this is an example of a constant series here. Okay. Then I have the sum as k goes from 1 to 5 of 3, which just means I'm going to add 3 together 5 times. Okay. So would it be easier to add 3 together 5 times, or would it be easier to multiply 5 times 3? Okay. You know, it just kind of depends on the mood you're in, I think, which one's easier. So they developed a formula for that I can just multiply n, whatever my value of n is here, times c, whatever that constant is. Now the thing is that sometimes it doesn't always start at 1, so you have to make sure you're doing it the right amount of times. Or if we had a linear series, a linear series here as k goes from 1 to 10 of just the value of just k, which means all I'm doing is adding the numbers 1 through 10 together. And they use that to develop a formula here to be able to do a linear series. That if I take my value of n, my top number here, multiply that by n plus 1 and divide by 2, I can get the sum for a linear series. Well, you can either use that formula or you could just add up the numbers 1 through 10. Okay? Some people find it easier just to add them up instead of trying to figure out the formulas. And you know what? That's okay. And they also have one for a quadratic series. That if we have the sum as k goes from 1 n of k squared, so a quadratic, then we can put n into this formula and find the value of it. And so any of those are basically up to you what you do, whether you just write down the whole series and add them up, or whether you use the formulas, it doesn't matter. It's your personal preference. So if you like formulas, then these are, the first 2 are pretty easy to use. The last one, some people find that a little bit harder. Okay? But you can just add them up also. So for letter A here, we want to evaluate the series, the sum as k goes from 4 to 10 of 6. So if I just expand it, let's look at that one first. If I expand it, that means we're going to add 6 together 7 times. 4, 5, 6, 7, 8, 9, 10. Okay? There's 7 numbers there. Some people think there's only 6 here when I go from 4 to 10, but there's really 7 because you got to count the 4 and the 10. All right, it's not like subtracting. Right? So I could do add 6 together 7 times and get 42, or I could just do 7 times 6 and get 42. Right? It's basically your personal preference. Whichever one you want to do, by golly, you go ahead and do it. Okay? Okay, the linear series. Right. Here we want, as k goes from 1 to 8, expand k. So if we just expand it and evaluate, we're adding the numbers 1 through 8 together. And you can just write down 1 plus 2 plus 3 plus 4 up to 8 and add them. Okay, that's pretty easy. The only time that gets overly difficult is if we had a lot of numbers. Okay, if you got less than 15 or 20 numbers, it's really not that hard to add them together with the abilities we have with our calculators. But if you want to use the formula, you could use the formula also. In this formula, so we've got, here's the formula, it's n times n plus 1 divided by 2 because it's linear. So my value for n is 8 here. So we're just going to do 8 times 9 divided by 2, which also is going to get us 36. So whichever method you want to do, you can do it. Or if it's a quadratic, same thing. If you want to use the formula, you can do that. If you want to expand it, add them together, you can do that. It's totally up to you. Now, one thing I will tell you is this, okay? That if you ever have a series that where it says sum as k goes from 1 to 7 of, let's say it was 2k squared. Okay? If it was 2k squared, then all you need to do is you could actually rewrite it, okay, like this. So what I can do is I could find the value of the sum from 1 to 7 of k squared and then just double my answer. Okay? So I would find the sum and then multiply it by 2. So if I had 2n, I could do the same thing. Just find the sum for n, or for k, and then just multiply it by 2, or multiply it by whatever. If you had negative 5 here, then we could just multiply it by negative 5. Find the answer and multiply it by that constant. All right, last one. Sam is laying out patio stones in a triangular pattern. The first row has 2 stones. Each row has 2 additional stones as shown below. How many complete rows can he make with a box of 144 stones. Now the best way to do this is just to make a table. And now I got start of a table here, and I'm going to change these columns. This is going to be the row number, okay, the stones in that row, and I'm actually going to make a third one here. And this is going to be total. So the easiest way to do this is not to worry about any formulas, okay, but to just go through and make a table and go through that table. All right. So I'll start and make a list of numbers. Okay, let's see. There's 2 in the first row, right? And that gives me a total of 2 that I'm using, doesn't it? In row 2, I have 4 stones, which means now I have a total of 6, right, that we're using. Okay. So what does it look? It looks like each time they're adding 2 stones, right? So what I'm going to do is I'm going to keep a running total then. As I'm adding rows, I'm just going to keep adding, keep a running total until I get to the point where I have the amount I want. So this would be 12, 20, 30, 42. Okay. And do that until I get to where I've used up was 144, right? Right? So if I went to row 12, I'd add 24. That would put me at 156. So that's more stones than I have. So I can do 11 rows of stones. And the easiest way to do that is just to make a list and keep a running total of where you're at to find that answer, which hopefully that's what you would do.